Okay, so yes, my talk today is called Mad with Power, the hunt for new compile time idioms. But before we get there, let's talk about what I've been up to. So we all know that in December 2017, I quit my job at Remedy, the intention to go off and do my own thing. And of course, I'm going to be using D if I'm going to be calling the shots, right? So my plan has been to make my own games and start up my own game studio. Quickly became clear though that that's kind of difficult to do. Like funding a game studio, no one really wants to do that. Funding a tech studio, that's a far more reasonable prospect to investment people. So it became apparent to me though that the kind of games that I want to make need a common tech solution. And after talking to a large number of people across the games industry, it became apparent that there's definitely a demand for the kind of product I have in mind. This is essentially a narrative middleware that aims to drastically reduce the cost of storytelling in interactive media. And the idea is get the tech self-sustaining and profitable, and I can go off and make my own games. Woo! Of course, the obvious questions for investors is, why D? The big one that I say is that using C++ just takes me 10 times as long to write equivalent code. Why should I waste 90% of my time when I don't have to? And that's a very definite cost saving when you put it that way to business people. Now, D isn't widely used in commercial applications just yet, which might make it seem that it'd be very hard to hire quality programmers to work at this company. And I'm preaching to the choir here, don't worry guys, but we all know that D is a very logical choice moving on from C++, especially if you're already familiar with C++ or C#. Honestly, I find myself writing so much workaround code in C++ and C# compared to my D code, and the logical conclusion is it's easier to write clean code in D, which also means it's easier to maintain. But there's still things we need to do to keep this code clean and understandable. Programming standards, documentation, you know the drill. But I got to thinking, surely leveraging D's introspective capabilities would also be able to greatly promote code maintainability, right? So rather than just starting this code base to get something done, I started the code base with two things in mind. First, it needs to be performant. Of course it does. I'm an engine programmer. Performance is like my bread and butter. It's a very critical interest for me. But it also helps keep server and runtime costs down, so good business case again. Now, the second thing, it also needs to be maintainable by anyone. So just as a result of just looking into the business stuff of writing pitch decks, talking to investors, getting face-to-face with people that will give me money, be it investors or customers, it's made one thing very clear. Once this business is up and running, my programming time is going to be very limited. As such, any code I need to write here just cannot fall apart if I can't pay complete attention to it. So let's talk a little bit about what my tool set is to give you an idea here. It will be a multi-user collaborative environment. If you think like Google Docs or any of those online multi-user things, it's a basic idea. And this tool set, it'll generate data for the runtime. And the front end needs to be done in C# and WPF. And that's basically the only framework out there that can deliver the professional quality and the 3D performance requirements that I need. And yay, WPF and .NET Core, woo! That makes my life so much easier for getting it onto Linux and Macintosh. Well, people are definitely going to use Macintosh at the very least, and there's enough Linux users around that, yeah, it needs to be a thing. So running on the client's hardware means that, you know, performance overhead from the .NET runtime, it's more than acceptable. And hey, thanks to all the work that I did in Bindaroo that I talked about last year, binding C#, that means that I don't have to write C# code for anything but the user interface, which is fantastic. And of course, the back end is completely written in D. And you can either run that on your local machine if you're in a single user mode, or you can even have it somewhere on a server in a single user mode, but you generally have it off in a server for multi-user mode. And this is aimed at game studios, so there could be potentially hundreds of active users at any point in time connected to this server. It needs to be performant, and subsequently, being written in D and with a performance requirement means that people need to understand this code base really quickly for when they go in and modify it. And that's really what this all comes down to here, code maintenance. You know, I've done enough C++ in my time, enough people I know say that they just hate C++, get me away from it. C#, popularity in desktop space, but holy hell, have you tried writing WPF code? The amount of boilerplate. Woof. Rust, cool new kid on the block, everybody's interested in it, but I have issues with their new macro system. I don't think that's going to help long-term maintainability, which, of course, D is where it leaves me. Thanks to its introspective capabilities, I can do some really interesting things that are understandable at a glance to people who don't understand the code base. And ultimately, that's why I'm here today, to talk about this kind of stuff that's not necessarily idiomatic yet, but greatly helps the maintainability of my code base. And this is one of the justifications for doing my talk here. I mean, everybody in this room, there's been a number of people talking about compile time and introspective stuff this talk. But outside of this group, not that many people doing it. And this, you know, you can see there's a lack of high quality tutorials, lack of good documentation and so on. I constantly find myself coming across problems that I can't Google and solve. And since I've been taking more of an educational role in the games industry these days, why not just present it as something of a ground-up introduction to introspective programming while I'm at it? So this is basically a crash course tutorial if you don't know anything about it, as well as all the cool stuff I'm doing. Cool? All right. So template parameter parsing is the first order of business. So we have all seen code that looks like this. A function with a bunch of Boolean parameters and invocations that come down to just a string of true-false literals. And that is just plain unreadable at a glance. You need to follow that function to its function definition to understand what's going on. And there are idioms that people have set up over the year to help. You can define an enumeration that is basically a Boolean. It has off and on. And you can start understanding that at a glance without having to trace everything back. And of course, we're in D. There's a library solution for that. Over in standard typecons is a little template called flag. You instantiate it with a unique name so that you don't get type clashes, and then you get basically what you just set up with that manual enumeration. But then we have a problem. What if we only ever want to set this final parameter? And, you know, what about if it was the 11th parameter in an 11 parameter function, you know? And, you know, you can probably think of a number of solutions there too. But what if you have this same problem with template instantiation? I mean, unreadable Booleans on a function is one thing, but on a type declaration, especially on a type like this one that changes its layout according to these parameters, it becomes massively unreadable. And, you know, everybody's thinking, you can solve this with default parameters. Doesn't satisfy me in the slightest. We're writing D code. We can do so much better than that. So, let's have a look at variadic template parameters. Specifying variadic parameters, that's easy. You just add 3 dots to the end of an identifier, and yay! Now you have a tuple of n elements, and the number of elements is exactly how many parameters you instantiate it with. So, I mean, everybody should know what a tuple is, but just in case we don't, it's an ordered collection of elements. But unlike an array, which explicitly expects type values, tuples can be arbitrary as long as they're legal. So you can have types, values, or just, you know, there's a function symbol in there. How great is that? And because it's variadic, off you go. Give it as many as you want. And it just handles that. No extra work required. Okay, so if you do have those first 10 parameters that are important, but a user only wants to set one, there is a neat little paradigm you can take for that, which is assuming any parameter given to your template there is just an override of the default. If you instantiate that with 0 parameters, it's a legal object. And as like I said, you have to assume 0 parameters. This is it's critical, basically. So with these assumptions, you parse the variadic parameters for changes to the defaults, and you achieve that with the static for each down here. It's exactly like a normal for each, except it happens at compile time with compile time symbols. Pretty intuitive in that sense. So let's head back to our example here. If our struct takes 0 or more parameters and their order does not matter, then we can start rearranging this old code here. A bit of shuffling about, a bit of magic, and ta-da! A single enumeration that overrides the defaults. And just for the heck of it, I've made it a string enumeration and given it descriptions for their values. Unlike the previous slides, though, it is entirely unnecessary to specify that first important param now, since the default will be no. Specifying it basically means you've changed the functionality to yes, undesired. So, this leads me personally to an obvious question. If I want to store these parameters, how do I do it in an efficient manner? Maybe you'd include an associative array and just boolean to the parameters there and just set the overrides as they come. I mean, it's readable, not exactly memory efficient or anything. So this is where you can start getting creative. Pro tip, with any given enumeration, we can generate a bit field, which means we need to get right down into doing some introspective code. So, first things first, it is possible to get every member of any given enumeration, and that is done with this all members trait. You give the type that you want to get all members of there, and it will return a tuple. With every member is a string, and it is the name of that object member. So the comment down there at the bottom there, if you did a pragma message of your all params alias there, that's what you get. It tells you it's a tuple with a string important, another string, another important. Whew. Anyway, once you have all those parameters in a tuple, you can go ahead and iterate over it. And importantly, whoa, what happened there? Everything broke. Since it's a set length, that first red box, we can also statically size our Boolean array. Yay! And at that point, it's just a matter of checking if your overrides contain the parameter. And if it does, you can go ahead and mark it set there, like I do in that bottom line. And for those that don't quite understand this code, there is a little bit of magic here. The mixin keyword, which essentially generates code from a string. And I'll come back to that one later in this talk. So that's all well and good, right? There's a small problem that this arbitrary template parameter specification has introduced. Have a look at these two separate invocations. These are functionally identical. They'll generate the same code basically, but because they specify their parameters in a different order, they end up becoming different types. So the code gets generated twice, and that's not good. I mean, you couldn't do an equivalence check like that unless you templated the equivalence operator and blah, blah, rubbish. Don't do that, there's a better solution. Pro tip, reducing template bloat. This little template might look confusing at first if you're not comfortable with everything I've mentioned yet, but hey, for those playing at home, just go back and look at the slides, you can rewind. The basic gist of what we're doing here is that we're going to take any arbitrary enumeration, doesn't matter as long as it's an enum, and with that, iterate over every member of the iteration. Do not care what its value is. We only care how many entries there are in this enumeration. And each entry becomes an index into a linear array. Which means for each enumeration member, here's that mixin again. What we're doing is generating a standard property, resolves to bool, that you can call at compile time, assuming that you have assigned this to a compile time variable. Now, one last thing that finishes this little struct off. And it is one of the more unknown but unbelievably useful bits of D syntax. We create a constructor that takes an array of our enumeration entries and then add the variadic specifier to the end of that. And what does that do? Somebody in the audience must know, right? Just yell it out. Yeah, basically. So it just transforms your parameter list there automatically into an array. Give it any number of parameters, you'll get an array. Give it 0 parameters, you'll get an array. Give it 20 parameters, you'll get an array, which means you only need to write this constructor once to handle any number of entries you want to set. So now that we have all that, we can rewrite our structure entirely. So it's no longer a variadic template. It explicitly instantiates with an instance of a bit field from our enumeration. And thanks to all those properties we've generated, we don't need to do anything super complicated. It just looks like a completely readable static if branch. If the user has set important param, then we have an integer. If the user set another important param, we have a float. That looks fantastic. Now, instantiating it though, not exactly convenient. You have to inline to construct that bit field or assign it to an enumeration. So it gets messy, it gets messy. There's a way to fix that. We'll get back to it later. So Next order of business, code generation with external introspection. Isn't that a funny term? External interest, outside, inside, whatever. The general idea here is that we will use D's introspective abilities to not tell us anything about the internals of an object, because we only care essentially about what clothes it's wearing, what are its threads, you know? And to illustrate what I mean, let's go with an example. Let's say you're making a client-server application. Let's say theoretically it's the one I mentioned earlier. At a simple level, you know, you'll have a server there and you'll have a bunch of clients. They'll be communicating backwards and forwards with the server, pretty standard stuff. And the way they communicate with each other is messages sent across the network. So now we need to looking at problems in terms of network transmission. So let's start breaking it down. What is a message? At a conceptual level, it's an action with associated parameters. Cool. What else do we have in computing that's an action with associated parameters? Well, that sounds exactly like a function to me, you know? And if you were to implement a function across the network, you might even call it a remote procedure call. If you've used Unreal Engine, that's one of the things you'll have to deal with. But how would you implement a remote procedure call? So we've got to continue breaking it down some more. So we know what a function is, it's an action. But what is a set of parameters in a function? It is essentially a meaningful aggregate. And you know what? That actually sounds really interesting because that sounds just like a struct or a class. So in our case, we'll just use structs because it's a type, value type, not a reference type, much easier to deal with there. And the type of the class basically steps in for, you know, what is the action we're doing. We don't need to do anything else to define it. The members themselves, they're the parameters. It's an aggregate, just like a function parameter list. And one advantage of making all your messages of structs, if you try to put default values in there, you don't have to reorder your function. If you only want one default parameter, you don't break the readability. It's just there, doesn't matter. It's great. So this is a simple little message. It lives in a module just like an ordinary struct. So the question is, how do we make our code aware of this? The aim of our code here is to completely automate it, right? So if you remember earlier, we use the all members trait to get every member of an enumeration, but that's far from its only use. Like, if you give the all members trait a module for its symbol is a module, you'll get a string tuple of every object in this module. So if you were to print out the string of it to your compile log, it'll just look like that down the bottom there. It's a tuple with important message. In reality, you also get object and a bunch of other things that you have to ignore, but those are implementation details. Very quickly with this little method though, we do come across a problem, right? Because no one just has one struct per module. Nobody does that. So very quickly, your modules will get filled up with objects that you don't care about. You don't want them to be messages. They shouldn't ever be messages. And that's kind of bad. But that's where another language feature comes to our rescue. D has user-defined attributes. Now, what are they? According to the specification, they are compile-time expressions that can be attached to a declaration. And they can be queried, extracted, and manipulated at compile time. But how do you define them? Well, this one's pretty easy. You just add an @ symbol in front of a symbol before your definition there. And much like tuples earlier, these symbols that you can attach to a struct or whatever can be anything valid, like user-defined types, value literals, and even functions. It is worth pointing out, though, if you're doing the value literals, you do need to add those brackets like I have there with the floating point example. So what we'll do here with a UDA is we'll define two separate types here, a server message and a client message. They exist for no other purpose than to be a UDA, and they're completely empty. So to tag up our messages, this is exactly how we would do it. We've got a bunch of ordinary messages here. You tag it with server message, that means only the server can send this message. Likewise, tagging it with client message means that only the client can send this message. But what if there's some basic functionality there, like a ping and a pong for a ping response over the network that both will handle? You just tag them with both. Simple. And this is self-documenting, clean, and entirely functional for the rest of the code we're going to write. Now, here's a little pro tip. Yo, all right. Volume. No, we need volume on the mic.
Testing, testing, testing.
Just speak loud.
Okay, so there's an even nicer trick that you can do with these UDAs. Is it on again? No. Where's the switch?
He controls it with, oh, there's a switch on it too. Dude, post it on the forums or something, man. Oh, wait, hold on, we're good.
Yeah. So you can define an enum called message, which has maybe members called client and server, and then you can tag with message.client, message.server, and then you can have checks which just say, is this thing tagged with message? So
yes, you could do that, but this also, I'm going to slightly get into the same kind of area there, because you can do UDAs that way, but one thing in common with all of them is that I make lots of UDAs, and I never have found a really good way of sorting them in code. What, do you put them all in one file? Do you put them in a file with everything else? Whatever. Until I realized the problem here was literally staring me in the face. Just make a UDA that denotes that this is going to be a UDA. And so our client message and our server message is now explicitly UDA to be a UDA. Problem solved. You want to know what a UDA is? Just run a search for that in every file in your project. You get a clean list. Perfect. So that is an excellent tip that I recommend everybody use. All right. Sorry, you're going to have to wait for the microphone. My hearing's shot. Say again?
Don't you have to annotate UDA with itself?
I mean, it's already self-documenting. Why do you need to add more? Okay, so let's continue. We have that UDA, and now we need to work out... Hold on, I read that wrong. So now we have a UDA. We need to work out how a type has a UDA applied to it. The way that the compiler provides, there's this getAttributes trait, which gives you every attribute applied to that symbol in a tuple. Tuples, yay, we love tuples, right? You're very quickly going to find yourself doing busy work if you just rely on that. There's better options, such as standard traits. That has a bunch of handy helpers there. This one we're interested in is hasUDA. You give it a little type, you give it something to search, and it'll let you know if it's there. But have a little look down here at what I'm going to do with these enumerations. These are templated enumerations, and they'll resolve down to a single Boolean, wrapping the hasUDA thing. Why would I go to all the trouble of creating these enumerations, though? Surely just using hasUDA is enough, and you just use that everywhere? Well, what about if we want to take a tuple and filter it? So standard meta also has a bunch of handy filters for you, handy helpers here. And what filter will do in particular is take any uninstantiated template as the first parameter, and then the second parameter is a variadic template. So it'll apply that template to every single member of that tuple. And the end result here is that our alias will just get a tuple back that only has objects tagged with client message, and the server messages will only get ones tagged with server messages. Super understandable, and you could probably understand that at a glance. I don't know how readable filter is for somebody that doesn't know what a filter is, but do those people exist? Anyway, there's one problem I also haven't really dealt with so far, identifiers for these messages. Now, an object's type is great for checks at compile time, yeah, but we'll be receiving data over a network. We need to know what type it is at runtime. And there's an okay-ish way to manage this. Hash the name of your message. Any kind of hash function you want. I want a 64-bit one, so here you go. There's a function stub. Now, the naive way to do this would just be use the type string of, but this is what happens. You have module 1 with a type called struct. You have module 2 with a type called struct. Those two objects, despite being explicitly different types, generate the same hash name that way. Don't want to do that. So what you need to do is use its fully qualified name. That's a helper in standard traits as well that you can use. And that includes the module and packages names for a full string. And yeah, it ends up resulting in a deterministic type. That comment there is essentially what the template breaks down to. So that'll give you an idea of what kind of string you'll get from fully qualified name, and that's deterministic at that point in time. And there is ways to do it more efficiently for the code I'm about to show you, but again, this is tutorial level stuff. So we have all these ingredients, and now it's really, really, really easy to generate every message that a client or server will respond to with a static for each. There's that thing again. Static for each has come up a couple of times over the last few days, and good thing I pre-prepared a slide earlier to explain exactly what it does for those that don't know. So in this particular case, everything inside that code block essentially gets duplicated for every element of the tuple and customized with the template parameters. And thanks to more templated parameter functions, we just have a byte stream, it's a byte array. We can deserialize that into an instance of the message in question so that we can pass it along to a standard function called onReceived. And that now implies something. If you add a message somewhere in your code, you tag it up with your client message, server message, you hit compile, this will immediately error saying onReceive for your new message is not defined. So the programmer knows immediately what they have to do with this code. Now, you can certainly make that nicer, but that's the bare minimum right there for that. And since I care about performance, you can be sure I'll be checking each onReceive function to make sure that it's non-virtual and that it takes its parameter by const reference. So R-value refs, woo, please, please. Okay, ooh, I'm running late, probably because of the questions. The next thing I want to talk about is eponymous mixin templates. Now, eponymous templates, used all the time. Eponymous mixins, not really. This is another thing that's best explained with an example. So looking at our standard interface for handling a message, ping and pong, their behavior that the client and server will implement, the code will be almost identical. Now, if you're an object-oriented programming fan, maybe you do something like this. You'd create a base class for sharing the behavior to the two. That quickly degenerates into one of my pet peeves, inheritance hell. I'm not even going to get into that. Inheritance hell sucks. What about interfaces though, right? That's what we tried to solve inheritance hell with, just make everything an interface, right? I don't know, it just seems like the same problem but more verbose at the end of the day to me, so no, ignore that. So instead, I'm using mixins to duplicate the behavior. Now, a bit like that static for each earlier, the contents of this mixin here, it's just dumped wholesale into the code where you instantiate it, right? So you could compare it to macros in C and C++, but A, please forget about macros, and B, that's really underselling them. But you could start getting an understanding of what they do just by thinking of them like that. Now, there is something that became clear to me when I started using mixins like this. See, I like partial classes in C#. You get a massive class, you can here's a little folder, here's every file for the folder, that's great. It's kind of tied into the object-oriented way of doing things, but you can split your implementation across multiple files and not have a 10,000 line file. But using mixins, we can do better. So we will formalize these mixins I'm doing into something I'm calling a behavior in my code. And behaviors will have two rules. You can only define one behavior per module, and the module name must be a lowercase version of that behavior name. And these rules are in place solely that we can automate it with another mixin template. So we'll add a UDA to say this is going to be a behavior. And then if you want to bring a bunch of behaviors into your object, you use this mixin template where you give it a string that represents the name of your behavior. And it'll go through and do some little magic like this, such as import the module that the behavior belongs to, and then mix in the behavior template. And so the ping pong functionality ends up looking like that. And then you instantiate it and dump it into your class like this. So here's a few extra behaviors that are kind of standard there. They all just get mixed in a reasonably automatic manner. So anyway, this actually does solve a little problem with partial classes. Because even though I said, oh yeah, you can make a folder, you put your partial classes into it, nobody really does that, especially not Microsoft. You make WPF code, it's a partial class, it's hidden somewhere, you've got to, whatever. So this does solve that to a degree. It tells you explicitly that you're going to have to go there to look for this behavior, but there are already problems with this approach. So ping and pong, fairly standard, but what if the client and the server need to handle it in a slightly different manner? I mean, the client is only connected to one server. It can make any assumption it likes. The server is going to have up to hundreds of clients. It needs to know what the hell it's doing. Where's the ping coming from? What should I do? It probably needs to do extra stuff like handle terminating connections and dumping all that stuff from memory. Functions are functionality is otherwise identical, but these differences are pretty critical. So let's just say, oh yeah, well it's a mixin template. Let's just give it template parameters. Cool. One problem though. The way I've set up my code, this behavior's instantiation, it relies on your string symbols resolving to an uninstantiated mixin. And there you are going and instantiating it. So it's going to try and instantiate your instantiated mixin. Boom! Not going to happen. All right, what can we do to solve this? And this is the first thing that came to mind here was eponymous templates. What about if I make a mixin inside an eponymous template that deals with this? So an eponymous template, if you're unaware, it's a template, you use the template keyword, you give the template a name, and you need to resolve something inside that template to the same name of the template. And it ends up being a bit like syntactic sugar, you can think. It just removes everything else and resolves down to what I'm doing here, which is the initialization value of an integer. And it can be any symbol, of course. So in this particular slide, instead of just making an enumeration, a compile time constant, I've given it a function. And just for the fun of it, you've also got a write line in there to prove that it is a function, but it's otherwise identical to the previous code. Oh, yes, all right, I'm getting there. Here's the good stuff. Now that we've explained what its eponymous templates are, we can actually revisit something that I wrote earlier. So you remember when I was talking about the bit field out of an enumeration. There's a, so inline instantiation, not necessarily convenient for the user that way, but if you want to do it a different way, there's a really convenient way to do it for the user and preserve this. So the first step is that we define a template called isParam. We're just checking if the type of the symbol passed in is of a parameter. It's that enumeration. Cool. And then what we do is we get the parameters from our variadic template list with this isParam thing. So it's a filter like we did earlier. And finally, to build the eponymous template, we'll do the instantiation ourselves and alias it to the name of the template. But have a look at this little bit of syntax here where I place brackets around a tuple. Now this is a kind of magic like the 3 dots earlier on an array. It turns this tuple into an array, assuming that they're all the same, assuming they're all values of the same type. Right? If it doesn't do that, boom. But if it is, well, I mean, we've filtered it, so it should be fine. Off we go. End result is that it no longer matters exactly at all what order you put your parameters in. You no longer need to explicitly instantiate your bit field. And this code generates the same type under the hood. Woo! Woo! Enthusiastic, excellent. So getting back to our behaviors, we have eponymous to template. So how about eponymous mixin templates? I mean, as long as it resolves to a valid symbol, it should be great, right? There's only one problem here. The mixin itself has absolutely no idea about the surrounding template. Knowing how mixins work, I'm pretty sure that's intentional. So that means we're going to need to work out a way to get around these. The solution here is a bit of good old-fashioned compile time code generation. And this is where I get to that mixin keyword I mentioned earlier. So string mixins. This is kind of what I call the nuclear option. What it does is you give it a string and the compiler treats that string as if you'd just written it like normal code, as if it had been read off disk during the compile step. And yeah, it's nuclear because the idea is that when generic programming doesn't work in any other way, you just generate a string that does exactly what you want and you force the compiler to deal with it that way. So this little integer I've been displaying up here, this mixin generates the exactly equivalent code. It's a string literal. This mixin generates the exactly the same code. It is concatenating two string literals, treating them as one string. End result is exactly that statement up above. And this function that returns a string, it's also exactly equivalent to the plain integer definition. I mean, I'm just instantiating the function with the integer down there. Boom, same result. So with that knowledge, you might be thinking, yeah, you can generate any string you want at compile time, right? By just running an ordinary function. That means there's plenty of power to be tapped. And that's kind of a point I want to make. I mentioned earlier that I'm not too happy with Rust macros. Whenever you're doing compile time work in D, it makes sure that at every step in the way you need to generate legal D code. No secondary languages, no additional code constructs, generate legal D code. And this is actually something I find critical for long-term maintenance because it's less that the programmer has to learn. All they need to work out is, what's the string we're generating? Legal D code. I can understand legal D code. Off we go. You can read it, you're happy. And honestly, anybody that's ever dealt with C++ macros, and it gets really messy. I don't see Rust being any better in that respect, the way they've done things. Legal D code. Anyway. Using string mixins, we need to generate code. Basically looks like this. The eponymous template resolves to a mixin that takes 0 parameters, simply mixes in another template using the parameters from the surrounding eponymous template. That's what the function looks like to do that. You give it a desired name, which will be the name of your eponymous template at the end. Then you give it another name, the mixin name, which is the actual mixin that you've prepared earlier. So in practice, that means that we've had to rename our ping pong template a little bit. We give it the little IMPL, which is short for implementation. It tends to be a common concatenation of that word in the compile time programming in D. And we just call our code generating function and then mix in the results of that. And why? It works. Readability is maintained, minimal maintenance, and it results in an uninstantiated mixin template that it all gets mixed in, it's happy, yay, maintenance is great. And I do use this myself. It's a massive success in one very critical location. Sending and receiving data across the network is essentially the same code for client and server, but they have different messages. So no virtuals, no, I'm trying to be as performant as table, no tables, and nothing. Code generated at compile time, runs efficiently in runtime. And of course, if I find a bug in that send receive code somewhere, it just immediately gets fixed for the client and server without going through the nightmare of multiple class inheritance. Whew, I'm on time again. The last thing I want to talk about in depth here is templated UDAs, which is also something I use to great success, but I don't see too often. Okay, so earlier slide with the static for each. There's something in there that's really interesting to talk about if you're not an expert D programmer. And that's this line here where I deserialize an instance of our message from a byte stream. Deserialize, that's just a function stub there and it satisfies the requirements for uniform function call syntax. Those playing at home, Google that one yourself. But basically, the only parameter that this deserialize function takes is a byte array by reference, because the intention with this is that we consume it, so it'll constantly make the array smaller and smaller and smaller. Also takes a template parameter representing a type. How does it work there? Oh, glad I asked. Works like this. Ta-da! Can you read that? Okay, let's go through it. So you've seen me use the all members trait previously in this talk, but there's a really handy shortcut that just gets this every variable contained. Like if you've ever tried all members, it'll give you functions, any aliases you've got in there, literals, whatever. You just want the variables, you use that tuple of property, which unsurprisingly gives you a tuple of every member variable in the order of declaration. And again, using the for each loop where we track the index, we can inspect the type that we're getting there, deserialize the exact amount of bytes we need, and assign it to our output object using that index variable. Yay, that's fantastic, and that trick there will get you very far. But I have other things I want to consider. Like, what if there is a member in a struct that I just don't want serialized? I don't care about it. UDAs, woo, make a no serialize UDA. Tag your float up there, ignore this, no serialize. Guess what? We're gonna make it ignore this. So, oh, I had a box there, okay. So in our deserialize function, we add one little static if into our loop to check if we're allowed to serialize this member or not. We use has UDA again, member no serialize. Should be able to understand that by now. So, that's end result. Our byte stream is 4 bytes smaller because we don't care about that float. That's still not enough for me. What if I want to execute some code during serialization and deserialization? Now, if you've written this stuff in other languages, you could come up with 100 ways of doing that. Registering variables, making maps, virtuals. We're in D, come on, we're in D, we can do better. So how would I handle this? Well, let's have a quick recap of a UDA. Any compile time expression that can be attached to a declaration, like user types, value literals, functions. Cool. And as we should really know by now, an instantiated templated type passes as a user type that you can attach to your object there. So here's a little template here that's been instantiated with an integer and applied as a UDA to this struct. Cool. So here's a couple of other structs. They're taking aliases as the parameter. This is just really short for making the point, but the name of the struct gives away its intention. It's meant to be a function that gets called on serialization of this member, or deserialized, a function that gets called on deserialization. And because I'm a completionist, there's also a bunch like that. Pre-serialized, post-serialized, pre-deserialized, post-deserialized. It's a mouthful, but you need them. And here's a quick and dirty example of how they'd be used. So this is a kind of a common example from game development, right? Checking distances in three-dimensional math, square values, far quicker to do it. But normal people don't think in an exponential scale. They think in a linear scale, so they want linear distances. So the idea here is that it serializes to disk in a linear scale. Anybody inspecting that data on disk or wherever, they can read it. But because it's quicker at runtime, we deserialize it to the exponential square curve. And that's prepared for our computational needs, ready to go. It's pretty cool. And integrating it, well, it's also as easy as that no serialize logic. Sorry, place a static if that checks for your on deserialized UDA. And if there is one, instead of writing the deserialized value directly to our output, we instead pass it as a value to the provided function in the UDA and write its return value to the output. Now, the other UDAs work in a similar fashion. I'll leave that as an exercise to the viewer to work that out. There we go. That's pretty cool, isn't it? Really flexible serialization library, fully exploits compile time reflection, similar to how Steven showed us all earlier with his stuff, except now I can call code whenever I want and it doesn't become a mess and you can just look at it and it's maintainable. Woo! Fantastic. I love it. What have I got here? Yeah, I was making a point again about that, but instead of that, I will just actually show a bit of a live demo. I'm going to hit run on my project here. So anyway, this is just some of the stuff I'm doing here. I'll get this. So this is what we're calling it. We're calling it Smithy, which Smithy is the name of the tool set. And it's just aiming to be where you go to create the ins and outs of interactive narrative development. So we'll do this, which instantiates a server that we connect to. All that stuff's being done in D code. And then we've got our interface here. This is an empty project. So we can fill it with something. I don't know, what about a narrative? Let's add a new narrative. Now, so this is if anybody is familiar with Final Draft Pro, it is screenwriting software used by professionals to write their scripts. And this is one of those critical things for me. I can make tools that game developers can use, but no professional screenwriter will want to. So if someone can come in here and go, int this room in London, then we go down here, I'm up on stage talking to people, woo! Let's prove that by giving myself a dialogue option. Whee! Okay, there we go. That's essentially the functionality that a professional scriptwriter expects. And that's all done in WPF, but all the data structures are written in D. So the binder is being used there to communicate backwards and forwards with that. It's all being handled on the server. Still haven't got the multi-user connections up and running yet, but that's coming. But yeah. There's one reason why I'm going to all the trouble of recreating Final Draft Pro here. Let's import a document that was prepared earlier. So for those that don't know, I actually voiced a character in a video game last year. It was actually put up for an award, National Video Game Archive or something. My competition was John DiMaggio, who voiced Bender in Futurama. Yeah. Guess who won that one? But yeah, this is just a little snippet of the screenplay here. He wrote it in Google Docs, and he's like, this sucks. So, you know, when can I use your tool? Here's a test, make it work. So this is just an HTML export from Google Docs. We've imported some, hold on, I'll click, is the back button? There it is. Come on, back. Back, there we go. So yeah, this thing that I did here is just some regex expressions to do some filtering. There's extra D code that supports that a bit better. But you know, every kind of document you want to import does things a little bit differently. So you click the review button because it is code that I'm making a best guess. So you can come through here. It'll give you a token stream of everything it's found. This is kind of more for a technical person, I guess, to deal with. I need to work out a better way of dealing with it, such as giving people a script editor that they can modify the imported stuff indirectly before they continue importing it. But the idea there is, everything's imported. You can go through, fix whatever you want before you hit the accept and import. And this task's already done. I'm just getting 100 WPF exceptions here, so it's got to give it a second, 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 give it a second. Come on! Guys, never, okay, this is running in release, but never, ever, ever run WPF code in debug. It's just not worth it, not even once, all right? Oh, but hey, look at it, we've got the import. So the general structure with these things is that I call them narratives, and inside narratives is routine. If you're doing an interactive story, it's not linear like a script. You know, it comes a bit more like a sketch show in a sense. So you've got to do routines that happen independently wherever the hell you want. So it's all split up into routines. And there you go. There's dialogue. There's more dialogue. This is why I wanted to recreate Final Draft Pro, because there's no way in Final Draft Pro or any word processor to handle branching narratives. So whenever you need a branch, it's just a little tab here that you can interact with. You want a new option? Ooh, there's a new option. You want conditions to that option? There we go, we add conditions. Yeah. This will all get exported to whatever format you're working with. This interface definitely needs work. I need feedback from professional screenplay writers about it. Game developers always ask me, what about a flow editor? This one does flow editor. I'm like, what about a flow editor? Woof, it's just another view of the data. You know, data view models, we've had this concept in computing for what, 30 years? Why is this still a question to people? Come on. This script writer is just the first part module. There's plenty more that I can go into separately, like you manage characters, you manage the actors for the characters, and that's just a fraction of the functionality. But we have hit time, so now it's question time.
This is a question about your last software you show us. Will you
speak up a bit, please?
Will you support Twine export?
Yeah. Oh, that's also easy. I mean, Bandersnatch was written in Twine, right? And I'm just like, well, I mean, these are professional Hollywood screenwriters writing in what is basically formatted Notepad, right? And here you go. They can just live in an environment they're native with. So this is something. I don't know any contacts at Netflix yet. So if anybody knows anybody, introductions would be appreciated.
So in the struct serialization functionality that you described, have you attempted to support versioned data structures and automated transaction between them?
I haven't really gotten into versioning yet because my code base hasn't gotten that complicated. I'm considering versioning the best way. I mean, we can generate a hash of every member and just generate it it's kind of similar to what we do at Remedy. Like we can generate a hash of the data layout and say, no, this thing on disk is out of date. It's probably a similar approach I'd take, but at runtime. Okay. I mean compile time, not runtime.
How long does your code base take to compile?
Pretty quick at the moment. Hoping to keep it pretty quick. So CTFE when?
General point I wanted to...
Sorry, one thing. I mean, code I'm using there as well. I've got Jonathan's DXML library. I've got Adam D. Ruppy's RSD stuff in there as well. So I am using community code in here as well.
Just a quick point I wanted to throw in, since I've seen two people doing presentations using hasUDA and getUDA now. If you want to keep your code really performant, I recommend avoiding those because they instantiate a template for every symbol that you're inquiring. It's usually more efficient to write your own version of that just takes the attributes via the trait, and that way you only get one instance.
This is correct, and I have done exactly that in my code base. However, for tutorial purposes, I didn't want to explain that. So listen to that man, he tells the truth.
One more question? Okay, it's got to be the last one.
Do you have any thoughts on this code-generated serialization techniques compared to like a different technique like protocol buffers, which have like a standard format and then they just generate code for different programming languages?
Why do I need to standard format anything? I mean, this is the same thing that the Wecker.io guys have. They know the exact code layout. Why do I need to put a layer on top of that?
All right.
Thanks.